Hey guys, and welcome back. In this video, I'm just going to do the third problem from the recitation assignment. And in this one, same exact thing as the first two problems. We're taking a rectangular form complex number. This one is -4 plus 2j. You're taking this number that's in rectangular form, converting it into polar form. So if you want to pause the video, now's a great time. And I'm just going to assume that you've unpaused it. So now, just like we've been doing in the last bunch of videos, we have to take this and translate it into something of the form magnitude times e to the j phase. So one thing I want to do, and well, let me just start out and I'll go ahead and plot this on our real and imaginary axes that we've got. So now I've got -4 plus 2j. So if I plot that, I have -4, 1, 2, 4 in the negative real direction, and then +2 in the j direction. So that's where my dot would fall. One thing I just want to say before, first off, let's just figure out what our magnitude would be. We have our magnitude right here. Actually, draw magnitude is right there. And the magnitude's just going to be the same exact thing that we've had in all of these videos, right? We know that our real side, our magnitude of the real part is 4, magnitude of the imaginary part is 2. So just like we've had before, our magnitude is 4 squared plus 2 squared, the square root of that. And then we're going to have 16 plus 4, that gives us the square root of 20, which is equal to 2 root 5, just like we've had in all of these other videos so far. And now we have to figure out what the phase angle is. So now, one thing I just want to mention about this problem, and it's something that's going to come up a lot. Whenever you use the inverse tangent function on your calculator or whenever you're writing stuff out, in order to figure out a phase angle, whenever you're in, let me draw it like this. If you're in the first quadrant, or if you're in the fourth quadrant, if you just put in the exact values, so if I just say, okay, inverse tangent of, let's say I had a number down here, -2j plus 3, or 3 minus 2j, say I had that number. I can just figure out my phase by doing arc tan -2 divided by 3. That'll exactly give me my phase. That'll give me this phase angle. It'll be a negative angle, and it'll be correct. It'll be the correct angle. However, whenever I'm over here, whenever I'm in either the second quadrant, or if I'm over here in the third quadrant, I have to remember that if I use this, if I want to get a phase angle that's anywhere over here, anywhere over in the third quadrant, or the second quadrant or the third quadrant, I have to, if I want to figure out that phase angle, I have to take the arc tangent of the imaginary part over the real part and add pi to it. Whenever I'm over here in the second quadrant or the third quadrant, I always have to add pi to that angle. So now I have that situation, right? Because I'm over here in the second quadrant. So I'm going to take, I've figured out what my magnitude is, and now in order to get my phase, I have to take the arc tan of my imaginary part, which is 2, divided by my real part, which is -4. And that's important. Whenever you're doing this, you have to make sure that if something is negative, the negative stays in the real part, or stays in the imaginary part when you do the arctangent function in order for this whole thing to work down here. So I take the arctan of 2, my imaginary part, +2, which is my imaginary part, and divide that by -4. -4 is my real part. And then I have to add pi to that. And that'll give me my phase angle. So let me go ahead and get the calculator back out. And I've got, so this is just 2 divided by negative 4 is, again, it's just 0.5 negative. And I'm going to take the inverse tangent of that. I get this, and then I have to add to that pi. And I get that my phase angle is 2.6779. So I get that this, my phase angle, is 2.6779. So now, if I want to write this number in polar form, minus 4 plus 2j, that is equal to 2 root 5 e to the j 2.6779. And that's it. That's the answer. You could also do, just like I did in the last video, you could go from here and add 2 pi to that number. It would be the same exact number. You'd be representing the same exact thing. So anyway, hopefully that was helpful, and I guess I'll see you in a future video. Thanks for watching.